So, yesterday we did the equation of, we did the area of a triangle. Now, what I'm going to bring on to you now is what happens when the triangle is not located, when one of the points is not located at 0, 0. In the first couple of questions, it was really easy because there was always a 0, 0 in every question. And that was really easy and convenient. Now, when we get to question 6, we see that we have to get the area of a triangle. The triangle is located at -5, -3. That's one of them. It's located at 1, 5. 1 across, 5 up. That's the other triangle. And finally, the last point is -2, 1, which is this point here. Now, they decided to give me a very fancy question straight away. What's wrong with this question? It's a straight line. What's the area of a straight line? Area of a straight line is 0, because it's a line. Line has no area. Okay, so given that we drew it out and we can see that it's a straight line, we know that it has no area. Now, that's beside the point, right? What I wanted to do, I'll use question 5 instead. What I wanted to do was to show you that this one's 5, 0. 1, 2, 3, 4, 5. We have 1, 3, which is this one here. 6, 2. And we want to get the area of this triangle. Everybody alright with that? Now, the problem is, the formula we used yesterday, everybody listening, is a half x1, y2 minus x2, y1. Or basically, a half, put them in, whatever number you're looking at, put it in and calculate it out. It's very easy, okay? Now, the problem is none of them are on 0, 0. Would you agree with that? None of them are on 0, 0. So, here's how you rectify this problem. You're going to make a similar sized triangle, except one of the points is going to be on 0, 0. And here's how you do it. Choose the closest point to 0, 0. Which is the closest point to 0, 0? 1, 3. To go from here to here, what do you have to do? You have to go down 3 and across 1. That's what we're going to do. This is known as a translation. We're going to do a translation of down 3 across 1. 1, 2, 3 across 1. Down 3 across 1. Down 3 across 1. Now, what results from this? What just happened then? We've made a new triangle. What's the similarity between the new triangle and the old triangle? They're the same. The lines are parallel to each other, but they're the same size and hence the same area. Now, what I'm going to ask you is, what's the points on the new triangle? So what we're going to do is we're going to change the old question into a new question that has 3 new points, and these 3 new points are going to be one of them is going to be 0, 0. So the first one is 0, 0. Everybody happy with that? Second one, 3. Oh, sorry, you're right. 4 minus 3. You're right. And then 5. 5 minus 1. That alright? So we've made a new triangle of the same sizes. Now look what happens next, guys. x1, y1, x2, y2. Put the numbers in, and we find it's 4 times minus 1, 5 times minus 3. It's going to be a half of minus 4 plus 15, half of 11, which is going to be 11 over 2. Everybody happy with that? Okay. Try another one now. I'll try this one instead, alright? Now, these ones are parallelograms. Everybody see parallelogram? Okay. So, what we can do here is this. Question 11, if you will. What can you tell me about parallelograms? Yeah, the size opposite each other are equal. Now look at this one. 0, 0, yeah? 0, 0. 1, 3. 5, 5. 4, 2. Now, what type of object is that? Parallelogram, okay? Now, a parallelogram, if I see the way one of the points is on 0, 0, do you see that? What can you tell me about this here? If I, huh? Two triangles. Are the two triangles the same size in the parallelogram? They are. So, if we get the area of one triangle, and then double our answer, we'll get the area of the parallelogram, won't we? So, in effect, we can pretend that the bottom point doesn't exist. So just pretend that the bottom point doesn't exist. So, what we're going to do is we're now going to concentrate on one triangle. This triangle has what are the points on the triangle? It's 0, 0, 1, 3, 5, 5. And then we're going to use our formula, aren't we? A equals a half x1 y2 minus x2 y1. And then we're going to get A equals a half bracket 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 minus bracket 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 bracket. Now, what numbers go where, guys? What do you want to call 1 and 3? y1. And call that one? Does it matter which ones? Would it matter if I called 1, 3, x2, y2 and I called 5, 5, x1, y1? No, you get the same answer. Okay? So, what happens here, guys, is 1 multiplied by 5. You looking? And then 5 multiplied by 3. It's going to be a half of 5 minus 15. What's 5 minus 15? Minus 10. What's the modulus of minus 10? Just 10. And the answer is 5. This means that one of the triangles is 5. What does that mean about the other triangle? 5 as well. And what happens when you add them all together? 10. So the answer is 10 units squared. Is that right? 10 units squared. Okay. So, the next thing you're going to look at is question 14. In question 14, you have minus 1 plus 3. You have 0, 2. You have 5, 4. 5 up, 4, and then you have 4, 5. And we can see that that's a parallelogram, can't we? Everybody alright with that? Now, what's very important we do next is this. We pull the nearest one down to the origin. Which is the nearest point? Sorry? 0, 2. So what does that mean? Everything goes 2 down. And what shape will result? But moved. Okay? So it's the same question, but it's moved. Now, can anybody suggest what my next step is then? You start at the 0, 0. I moved everything else down too. Yeah, I can do that in a second. So what I can do is I'm going to cut it in half. Everybody see that? So when I cut it in half, what's going to happen is I'm just going to get rid of the regular ones. Just a lot of writing on the board at the moment. Oh no. Okay. So what we have here is this here. Now, do you understand that I have to go to 0, 0 and draw the diagonal up? So I now have a choice of 2 triangles. I can find, if I find the area of either triangle, what can I do afterwards? I can just multiply by 2. So I'm currently finding, so I have a choice. I can get rid of the point up here, or I can get rid of the point down there. So which one would you like me to get rid of? This one? Okay. That's 5, 2. So you want me to get rid of 5, 2, right? So I basically ignored the fact that 5, 2 was ever there in the first place. And now I'm left with a triangle. Very similar to the very first triangles we did in our very first question. Is that right? So our vertices are 0, 0. minus 1 plus 1, and the last one 4, 3. Now all I have to do next is use my formula, half x1 y2 minus x2 y1. Then I half of 4 different numbers that are going to get multiplied, and then 2, then take them away. Okay, what's my x1 y1 value? X1 y1 value? It's never 0, 0, so it's x1 y1 x2 y2. Now what happens next? Minus 1 and 3, 4 and 1. Then what happens then? Minus 3 minus 4, which is a half of the modulus of minus 7, which is a half of 7, which is 7 over 2, or 3.5.